Hey guys, Mr. Jenkins here, and we are going to kind of start to move forward now to the last kind of part of the unit. So the first part, everything we've covered since the beginning of the semester has been about solving systems of equations. Okay, now we're going to look at some inequalities, right? So today's lesson is about how to graph two variable inequalities. All right, so if you think back to how to graph a one variable inequality, that's usually done on a number line, okay? Our learning target is we want to be able to graph linear inequalities in two variables and then use linear inequalities when modeling real world situations. All right, so example one wants us to be able to ID solutions of a linear inequality. All right, so what you want to do here is just kind of sub and check, all right? Substitute and check, right? So remember that negative 2, 2, well, first of all, what are they really asking me here? Determine whether the ordered pair is a solution of the linear inequality. So in other words, is negative 2 comma 2 a solution of y is less than or equal to negative 2x plus 1, okay? So remember, this as an ordered pair means x equals negative 2, and y equals positive 2, right? So if we just sub in 2 for y, and negative 2 for x, then we just check to see, is it true, right? So the question is what I have in here true, right? So obviously we would want to simplify the right side there. Just in your calculator, negative 2 times negative 2 plus 1, that's going to be 5. So really that says 2 is less than or equal to 5. So is that true? The answer is yes, that is true, because 2 is less than 5, right? 2 is not equal to 5, but 2 is less than 5. And so the answer here would be yes. All right, looking at the next one, 0, 0. 0, 0 is important because we use what I like to call a 0, 0 test kind of a lot. So it's always easy to sub in 0. All right, so if I sub in 0 here, I get 0 is greater than or equal to. Now, what happens if I sub 0 right there? I don't even need to write that out. It's just gonna, doesn't matter that it's a fraction or whatever. Anything times 0 is 0. So I just get 0 is greater than or equal to 4. So obviously 0 is not equal to 4. Is 0 greater than 4? No, right? So this would be the answer to this question. Is that true? Is a big old no. All right, so there would be a way that you could use this for Desmos as well, which we'll get into later, but it's nice to be able to check those algebraically also. On that note, we'll go ahead and get to it. All right, so I'm just going to do several of these. The rest of them are worked out on your notes, okay? So let's start with B. B says y is less than or equal to half x plus 1. So when we're graphing our what I call boundary line, we want to just think about graphing y equals half x plus 1, right? So so then we would start at our b, which is 1. So start at 0, 1. And then from there, we'll use that the slope is 1 over 2, okay? So rise over run, so we go up 2, right 1. Now, I like to kind of go all the way across the page. I'll do that for the notes. You won't have to since you have Desmos, or sorry, since you have MathXL. So just bear with me for a second. I just want to make sure that I make a nice straight boundary line. Let's see, 1, 2, 5. All right, and then so now we make our boundary line, right? So step 3 is usually just kind of draw your line through it, but here you have to say, is my line solid, or I say dotted. I think the book says dashed, Is it solid or dotted? Or is it dashed, right? So in this case, it's going to be solid because of that or equal to. So that's what determines that it is solid. Okay, so I'm going to pull up a solid boundary line here. And there you go. So this is very similar to you know, what we did in chapter 5. So now that I have my boundary line, then the fourth step, the final step, is which side of that line do I shade? All right, so if it just is in slope-intercept form, like I can tell you y is less than is going to be below this line, but a good way to tell is to use what I call the 0, 0 test, all right? So 0, 0 graphically is right here, okay? So if we sub that in, we can see if that's part of my solution set or not. So based on what I said, we should shade below the line, we should get a yes, right? So we want to just sub in 0 there and 0 there. And when we do, we get 0 is less than or equal to 0 plus 1 is 1. 0 is less than 1, that's true. So you want to shade to the side of the line where 0, 0 is. So you'd shade right there, okay? And the shaded region represents all the ordered pairs that are yeses or are solutions to this linear inequality. So on that note, you still can use Desmos. So I wanted to show you a little bit of that too. I did want to show you one by hand. That's why I showed you that one. I would leave C for you. Now let's look at D, right? So D says y plus 2/3 x minus 2 greater than or equal to 0. So we notice y is not by itself here. So this may be one where, you know, you want to, that may be good to talk about Desmos, okay? So notice I typed it in just like I saw it, y plus 2/3, that's just 2/3, it'll make it into a fraction for you. X minus 2, and then greater than or equal to on Desmos. You guys will have questions, but literally you just type greater than and then equal, and it'll make a greater than or equal to and then 0. All right, now I'm just going to try to correctly take what I see on Desmos and put it onto my graph. All right, so remember Desmos, if you kind of click on the line, it's going to show you some key information. We've been looking at points of intersection, so this will show you where it intersects with the x-axis, so it goes through 3, 0, and with the y-axis, so 0, 2. So really that's all I need to be able to produce a good graph. So 0, 2, 0, 2, and 3, 0. All right, and again, I'm making these extra points just so I have something to aim at, but you guys will just have to make those too, and MathXL would finish your boundary line for you. So, and we can go over how to do these on MathXL as well, but basically you do the same thing you would normally do on a line, and then there's a paint bucket that you'll do your shading on. Now, notice Desmos does the shading for us as well. So we can see on Desmos that we've shaded above the line. So you could just copy that. Now we can also see that's true with the 0, 0 test. All right, so if we sub 0, 0, we get 0 plus 0 minus 2 is greater than or equal to 0. So that would just be -2 is greater than or equal to 0. That's not true. So notice we shade on the other side of the line. 0, 0 is over here, we shade over there. Not that we needed to do that because Desmos already told us where to shade, but just showing you that that does work. All right, moving on to the next example. This one is in standard form. Hopefully you know what to do with that. But again, if not, we can use Desmos in this chapter. So I'll go ahead and look at it on Desmos. So this is example 2E. Go. So just to save a little bit of time, I went ahead and typed these in. See, I typed it just like I saw it. 5x plus 3y is less than 15. Okay. So again, I'm going to make sure that I'm very accurate on my graph. So it goes through 3, 0, and 0, 5. 3, 0, and 0, 5. Now, what's also nice about Desmos is, look, it reminds me that, and we haven't done this yet, this one is a dashed line, right? It's dashed because this does not say or equal to. So again, that's a nice reminder. Just by using Desmos, we wouldn't make the mistake of making this a solid line. And that's where, you know, MathXL would count that wrong. All right, so I'm going to pull up a dashed line. What I was going to say is MathXL would count that wrong if you just did a solid line. So there's a dashed line tool that you can pick on MathXL. And again, this one is dashed because it's strictly less than, not or equal to. All right, so I have my boundary line. I can clearly see on Desmos that I'm shading below that boundary line. So that must mean that this one passes the 0, 0 test, right? So if I plug in, I get 0 plus 0 is less than 15. That's obviously true. So notice we shaded on the 0, 0 side of the line, okay? Also, again, remember how easy these are to graph, right? So this is in standard form. So it's as simple as my x-intercept is at 15 over 5, which is 3. And my y-intercept is at 15 over 3, which is 5, right? So remember that can be simple as well. All right, so let's go ahead and let's maybe look at F. I think that's worth looking at. So let's look at that one by hand and just remind you of a couple things. I see something there that we probably need to cover. All right, so going to be working with intercepts here, and you can always just punch it into Desmos. All right, so my x-intercept is going to be 8 over 4, which is 2. Okay, so it goes through 2, 0. My y-intercept is going to be equal to 8 over negative 2, so negative 4. So it goes through 0, comma, negative 4 also. All right, so at that point, I know my boundary line is solid. Do this one a little bit quicker than I have been. There's one thing I wanted to show you guys. All right, so if you're quick, you know, if you kind of get this real quick, you would think that says greater, you know, y is greater than, right? So we're going to shade above, but here is where the 0, 0 test is important, okay? So if we were trying to do this without Desmos and we wanted to know where to shade, watch what happens if we test with 0, 0. So what we would get is 0 minus 0, which is 0, is greater than or equal to 8. All right, so is that true? 0 is not equal to 8. 0 is not greater than 8, right? So 0, 0 is over here above the line, so that means we actually shade on the other side. So we shade below the line. So why would it be the opposite of what you would think? And the answer to that is if we solve for y, we would end up having to divide by -2, which would flip our inequality symbol. So long story short, you don't have to remember all that. You can either use Desmos or just simply do the 0, 0 test to see where the shading goes. All right, moving on to example 3. What does a one variable inequality look like on a graph? So we know, and I've talked about this, that x is greater than or equal to -1 could look something like this. On a number line, you know, -2, -1, 0, and then be a closed dot, shade to the right. Okay, but if they give me a 2-variable graph, then what's that look like? All right, that'd be the question. So let's look at Desmos. When in doubt, we'll use Desmos. Okay, so this would be example 3A. 3A right there. Open graph. All right, so what we see is a vertical line that passes through 1, 0, right? So on a 2-variable graph or a coordinate grid, if it says x is whatever than a number, that's going to be a vertical line. Just like you may remember, if it says x equals -1, I typed 1. Sorry, that should be -1, so it should actually be over there. So I just typed that wrong. I'm sorry. So even when you're using Desmos, you got to be careful. All right. So anyways, we also are reminded that it is solid because it's or equal to. Basically, we're just gonna. And remember, in Math Excel, you just put like a point there and then a point above it. And you know, on our number line, we shade to the right, and same thing here. We shade everything to the right side there. All right, so I would leave just the rest of those maybe for you guys. Actually, I'll just, since we have one, so we have one on the video, I'll do a y equals or a y is less than. So again, could just use Desmos here, but if we wanted to do by hand, we'd move the -2 over and get y is less than +2. So if x equals a number is vertical, y equals a number is horizontal, right? So that's going to be a horizontal line that goes through 0, 2. And again, you could be reminded of that by Desmos. This says strictly less than 2, so it's going to be dotted or dashed, whatever you want to say. And then we would shade on the, well, let's just see. Let's do the 0, 0 test. So -2 is less than 0. Is that true? That is true. So we want to shade on the 0, 0 side. So we'd shade below the line, which you might have already predicted because it says less than. So that would be below. All right, so I'll leave C and D for you. You can check those out on the filled out notes. And then our last type of problem are these word problems. Okay, so this goes right along with our 6-4 stuff we've spent so much time on. So example 4A says, for a party, you can spend no more than $12 on nuts. Peanuts cost $2 per pound, cashews $4 per pound. What are 3 possible combos of peanuts and cashews you can buy? So this person is a do-it-yourselfer. They're skipping in the grocery store the already assorted mixed nuts, and they're gonna do that themselves. All right, a go-getter. All right, so the first thing you want to do, even though this is an inequality, is still define your variables. Right, we're trying to find some number of peanuts, some number of cashews. So we'll just let x equal peanuts, y equals cashews. All right, step 2, we want to write our system. Okay, so we know that, or sorry, I said system. I'm just used to, I'm thinking back to 6/4. So these are just one equation. So anyways, it says, this says no more than 12, right? So that'd be less than or equal to 12. And our coefficient of x is going to be 2, because that's peanuts. Coefficient of y is going to be 4. So we'd have 2x plus 4y needs to be less than or equal to 12. If we were unsure on how to graph that boundary line, we could just punch it into Desmos. I'll go ahead and tell you real quick. My x-intercept is at 12 over 2. So it's going to go through 6, 0. My y-intercept is going to be 12 over 4 is 3. So also goes through 0, 3. 0, 3, 6, 0. And there you have it, right? So well, that's supposed to be solid, so let me try that again. I forgot I had the dashed one already selected. I go over top of that bad boy with the solid. Okay. So it wants to know then, basically now we're gonna interpret our graph after we shade, of course. So 0, 0 test to shade. So that's going to give me 0 plus 0 is less than or equal to 12. That would be true. So we want to shade the 0, 0 side. So below. I'm not going into any of the negative just because this is a real world problem. That just shows you that I can't stand between the lines. That's all that shows you. Okay. So what are 3 combinations that we could buy? I would say anything that's on the boundary line because it's solid. So it looks like 2, 2 would work. So let's say 2 peanuts. That's actually 2 pounds of peanuts, but I'm taking shortcuts. There's another one on the boundary line that would work. 4 and 1. So that'd be 4 x's, 1 y. So 4 peanuts, 1 cashews. And then you wouldn't want to use either one of these, even though that's on our boundary line, because that really wouldn't be a combination. That would just be 3 of one and none of the other. 6 of one, none of the other. So your other combination would want to come from the shaded region, say like maybe right there. So that'd be 1, 2. So 1x, 1 peanut, 2 cashews. So it's nice to see this visual representation too, because now I can tell you that with these 2 that are on the boundary line, that's where you would spend exactly $12. With this one, you would spend close to, but not quite $12. So here you're going to get some change, if that makes sense. All right, then our last one, we're not given a graph, so we're going to basically approach this the same way, but we're going to base our final answer off of Desmos. So it says, Mrs. Palmer has $140 to spend on games and movies at a local electronics store. The electronics store is hosting their annual sale where they sell games at $22 each and movies at $8 each. Let G equal, I'm going to change that to X just because we're going to be using Desmos. So let X equal the number of games, and M, the number of movies. We'll let Y be movies, okay? So X is games, Y is movies. I'm actually going to write that out. And again, the only reason I changed it from what the problem said is because I am going to show this on Desmos. And if I use G and M, Desmos is not going to really read that correctly. All right, so 22 is going to be my coefficient of movies, right? So that's going to go with Y. 8 is going to go with X, okay? So we'd have 8X plus 22Y. Actually, I did that backwards, sorry. It's games is 22, movies is 8. So let me flip those coefficients. Sorry about that. So it'd be 22X, 8Y. And then if we have $140 to spend, we could spend up to $140, but no more. So it's understood if you have money to spend, that's less than or equal to would be your inequality symbol. All right, so I already have that typed in. Again, we're going to base our last answer on Desmos. Give 4 combos that she could buy. I'm going to open up that last example. All right, so you need to understand kind of visually. Notice all this over here is shaded in quadrant 2, 3, and 4. Really, all we want to look at is the quadrant 1 part of the graph, because you can't buy negative games and you can't buy negative movies, right? So anyways, let's go ahead and look at this. All right, so we can pick just any ordered pair that's in there, right? So let's say we wanted to buy as few X's as we could, but mostly Y's, right? So we'd look maybe like here at 1 comma, what's that go up to? 1 comma 14, it looks like, is in our shaded region. So that would be 1 game with 14 movies. So that'd be one for like a movie buff. Say I wanted more games. So if I wanted to buy 5 games, I could buy up to, what's that go up to? 3 movies, right? 5 games, 3 movies. Oh, say I wanted to buy just kind of an even mix. So what if I bought, say 3, I keep forgetting what X is, sorry. 3 games, how many movies could I buy? That might be right on it. Just to be sure, though, I'll go here. So it looks like 3 comma 8 is definitely in there. And just say we're feeling cheap that day. So say we just want to buy 1 of each, right? So 1's definitely in there, and then we get a lot of change. So point is, any in this shaded region would be part of your solution set. Back to this one where it looks like we had a corner point on the boundary line, like maybe that one. You could always test that out, right? So you could plug in 2 and you could plug in 12 and see if that equals 140. You're definitely safe if you're in the shaded region. Remember, all these is where you could buy, that combination, you would get change back, right? So I kind of took a shortcut there too, but again, these combinations would mean, this would mean 1 game with 14 movies, 3 games, 8 movies, 5 games, 3 movies, or if we were feeling cheap, we could even buy 1 of each, right? So anyways, I'm sure you guys will have questions because this is a long lesson, and you will know you have questions as you start to try to work through the practice problems. So I'll look forward to hearing from you on those. Hopefully this helps. You guys have a nice day.